Hello guys, and welcome back to my video. So in this video we are going to be talking about natural language processing and how we can represent text. So the first way that we can represent text is we can use what is called character level representation. So one thing you should notice that when training sequence models the machine learning algorithms they don't understand text, but the best way that we can do is we convert text into numbers. So the first way that we can do is character level representation. So with character level representation, we represent text by treating each character as a number. For example, if we have a letter hello, we would take H as 1, E as 2, L as 3, and then O as 4. So that given that we have C different characters in our text corpus, the word hello could be represented by a tensor of C times 5. So each letter would correspond to tensor in a one-word encoding. So that simply means that if H is present, then we represent it by 1. If it's absent, we represent it by 0. And then the other way of representing, the downside of using character level representation is that each character does not give a meaning to the word. So the best way that we can do is to use what we call word level representation. So with word level representation is that we create a vocabulary of all the words in our text, and then represent the words using one word encoding. So this approach is better than character level representation because each letter by itself has so much meaning. So given a large dictionary size, the only downside that we have is that we have to deal with high dimensional space tensors. So let's talk about text vectorization. So if you want to represent words using word level representation, we need to do two things. The first one is we need to use a tokenizer that splits the text into tokens. And then the second one is build a vocabulary of those tokens. So let us look at word level representation using the tokenizer using Tensorflow library. So the first thing that we are going to do, we are going to import Tensorflow, and then from Tensorflow we are going to import Keras, which is a deep learning library that runs on top of Tensorflow. Sorry, and then from TensorFlow.keras.preprocessing.text, we are going to import the tokenizer. From TensorFlow.keras.preprocessing.sequence, we are going to import the paired sequences. So here I have encoded our sentences. The first sentence is, I love my girlfriend. I know many of you machine learning folks don't have girlfriends. I know many of you are geeks. I'm just joking, guys. And then the second one is, I love my dog. The second one is, you love my dog. And then the fourth one is, do you think my dog is amazing? So let us run our dependencies first, and then the first thing that we do is we need to initialize the tokenizer instance, and then we provide the total number of words, which is 100. In this case, 100, there are too many since our sentences are small. And then we need to fit our sentences into the tokenizer using the fit on text method. And then the tokenizer is a tokenizer.word index. This provides a dictionary that shows a map representation of a word and an index. So let us run it. As you can see, my is represented by 1, love is represented by 2, dog is represented by 3, I is represented by 4, you is represented by 5, girlfriend is represented by 6, do represented by 7, think is represented by 8, is represented by 9, and then amazing is represented by 10. I want you to note something. As you can see, I used the capital letter I in the first sentence, but the tokenizer uses a small letter I, as you can see. And you also see I used the punctuation, the exclamation mark and the question mark, but the tokenizer strips the punctuation from our words, right? And then the next thing that we need to do is we need to convert the text the text that we converted into numbers, we need to convert it into a sequence of text, or a list of text, a list of text sequences. As you can see, we do this by using the sequences. We do this by using the tokenizer. Okay, I'm sorry, so I'm just gonna run my notebook. So we do that by using the tokenizer to text to sequences. So what the text to sequences does, it's, as you can see, in this case we only have words. In this case we only had words. What it's going to do is it's going to convert our sequence of numbers representing words into lists. For example, the first list, it represented 4, which is I, and then 2, which is love, and then 1, which is my, and then 6, which is girlfriend. As you can see now, it puts them in a list so that we do not lose the meaning, so that we have the sentences. We now have a list of sentences. As you can see also, this second one, it's now you, 2 is love, and then 1 is my, and then 3 is dog, as you can see. And then if we use our test data, you can see that now we use our test data, which is I really love my dog. My dog loves my manatee. As you can see, from from using this 4213 represents my dog, represents my love, my dog. As you can see that we lost, as you can see now that we lost the word really, because our vocabulary is small. So when training sequence model, we need a large vocabulary, so that we do not have instances whereby we have a sequence like my dog. So we really need a large vocabulary. So the other thing that we can do to solve this is by using the OOV token. So what the OOV token is that words that are not seen in our dictionary are going to be given the word OOV. As you can see now, it now represents 1 OOV, I OOV, love, and then it's now it's now 5, it's I OOV, dog, my dog, as you can see. So unseen words are now represented as OOV. So the other thing is, as you can see, these sentences are not equal. As you can see, these sentences are not equal. They are not of equal length. The thing that happens is when we are training sequence models, you'll find that we usually include the input layer. So let's say the input layer only accepts 50 words. But let's say we have a sentence with 5 words. So how are we going to do that? As you saw, if you watched my video with sequence models, that we provide the input shape of an image that is 224 by 224, let's say, so that in order for them to fit them in the neural network, we had to resize the images so that they can be of equal length. So we do the same thing with sequence models. We use what we call padding. So padding, what it's going to do is it's just going to add dummy values, so that our sentences are going to be equal. So to do that, we import from TensorFlow .characters.preprocessing.sequence import paired sentences, and then we say paired sentences is called paired sentence, and then we pass our sentences. And then if I run, you can see that 5327. As you can see that we now have our sentences are now of equal length. As you can see here, they are now of equal length as we padded them there with 0 values, right? So now when we feed them into our neural network, we now have sentences of equal length. So thanks for tuning in, guys. If you enjoyed this video, make sure you click the like button and the subscribe button. So if you are not familiar with what is natural language processing, please watch my previous video. And if you are also interested in knowing what is image classification or how to use TensorFlow for image classification, please watch my image classification videos.